Hi Foundations of Business Analysis students, and welcome to this video presentation on the multiple regression. In a previous video we looked at a bivariate regression, which is a test for association between two variables. Sometimes what we want to test is not whether two variables are associated, but whether a group of variables, whether several variables are associated with one dependent variable. The way that we perform this test for associations with more than two variables, is through a multiple regression. A multiple regression is just an extension from our bivariate regression. It's an extension in the sense that the bivariate regression is just the first three terms here, y equals beta naught plus the slope times the x value. With a multiple regression, we're adding in additional x variables. So we're adding in additional variables that are trying to explain our y, and we're looking separately at the slope of each of these variables. A couple of important things to note with respect to the multiple regression. The most important thing, just like the bivariate regression, we're performing hypothesis tests on these slopes. A significant slope will tell us that there is a significant association between the variables. However, the slopes are interpreted slightly differently from a bivariate regression. In a multiple regression, the slopes are interpreted holding the other variables constant. For example, if we had two x variables, so we had a multiple regression where, let's say we're trying to explain house price as our y variable, and the two x variables were number of bedrooms and house size. In that case, if we found that the number of bedrooms slope was negative and significant, that implies a negative association between number of bedrooms and house price, which at first glance is not intuitive. However, the reason for that result is because we've got a second variable in the regression, which is the house size. Hence, what this shows us is how we interpret the number of bedrooms coefficient, in that this is saying that the relationship between number of bedrooms and house price is negative, holding constant the size of the house. So if you've got two houses of the same size, more bedrooms means smaller cramped rooms, which depreciates the value of the house. For a better examination of the multiple regression, let's jump into Excel and see how this can be performed. In this case, I might be interested in asking whether three variables, the age of the house, the number of bedrooms in a house, and the house area, can explain the sale price of a house. Now, when performing a multiple regression, the first thing we have to do is need to rearrange our data. A multiple regression can only be performed when our variables are located in columns next to each other. So what I'm going to do is I'm going to select my sale price, age, bedrooms, and house area variables. The way I selected all those at once was holding down the Control key when I clicked on each column, Control C to copy them, and then Control V to paste them in a new tab. So here I've got the four variables I'm interested in. Sale price is the variable I'm seeking to explain. That is my y variable, or my dependent variable. The three variables that I'm using to explain sale price are the house's age, bedrooms, and house area. We perform a bivariate regression in exactly the same way as a multiple regression. Therefore, we select data analysis and regression. In this case, I select my y range, which is sale price. Now I'm going to include the label in this because I'm going to tell Excel that my data has labels, which will help with my interpretation of the output. For my x range, remembering I've got three x variables here. I've got three variables seeking to explain sale price: age, bedrooms, and house area. So I select the three of those as a block. Click on age there, hold down Shift and click right twice, and then with Shift and Control both held down, I press down to select that block. I'm now going to ask that this result is, if I select output range, that will just enable me to select a point on this spreadsheet for the data to be reported, and I click OK. And here I've got my regression output. So just a couple of quick things to look at. First of all, we mentioned with the bivariate regression that the R-squared is a measure of the explanatory power of the model. For a multiple regression, we look at the adjusted R-squared. The adjusted R-squared is a way that we can compare models of different lengths, because the adjusted R-squared will add a penalty to the explanatory power for every additional variable you add into your model. In this case, our adjusted R-squared is telling us that our model does quite well. We can explain about 62.79% of the variation in sale price with these three variables. So our model has high explanatory power. Let's move down here and we'll have a look at the hypothesis test on our three coefficients, our three variables, age, bedrooms, and house area. If I start with age first of all, and I look at my hypothesis test, again, remember my null hypothesis is no association. My p-value is greater than 0.05, so I cannot reject the null here. I don't reject the null, so I say there is no relationship between age and sale price. Number of bedrooms. The p-value is less than 0.05, and here I've got a negative relationship. Okay, this is this strange result I spoke about before. The reason that there is a negative relationship between number of bedrooms and sale price is not because houses with more bedrooms sell for less. It's because we're holding these other variables constant. So if you had two houses that were the same age and had the same house area, in that case, increasing the number of bedrooms would decrease the value of the house. The last variable is house area. Look at the p-value, we can clearly reject the null hypothesis. As we expect here, we've got a positive association. Hence, a bigger house area, bigger floor space, results in a more expensive house. So that's how we can perform our hypothesis tests on a multiple regression model.